Today we're going to have a look at the cosine rule. Just like the sine rule, I've put up how to get to it, and I suggest you have a go at working through the steps yourself first. This is a right angled triangle here. It's far more satisfying if you can get to the answer without being shown it first, so pause the video and have a go. Okay, part A says find an equation that links A, B and cos x. So I'm having a look at this triangle. It's a right angled triangle and we've got A, we've got B, well B is the hypotenuse and we've got x, x is our adjacent. So we can say cos A is equal to my adjacent over my hypotenuse, and that's part A. Then we're asked to use Pythagoras to find two different expressions for h. Well, looking at this left-hand triangle, we can say h squared. Well, because it's not the hypotenuse, I'm going to have to say h squared is equal to b squared minus x squared. And then for the second expression, I'm going to have a look at this right-hand triangle. And I'm going to say h squared is equal to, well, my hypotenuse is a squared. And I'm going to take away the short side squared, c minus x squared. So it's just rearranging Pythagoras to get to this. And we want to get to this formula. So if I have a look at my equations, I don't have any h's or x's, so I want to eliminate h and x. The easiest one to eliminate is h. We've got our h squareds, so I'm going to eliminate those. I'm going to do that by saying b squared minus x squared is equal to h squared, a squared minus c squared is also equal to x squared, so I can put them equal to each other. The next step I'm going to do is I'm going to expand my brackets. So just be really careful as you're expanding your brackets not to make a mess of your minus signs. So I'm going to make sure that I put it all inside a bracket, and then when I write this out, I'm not going to make any mistakes, so I will end up with my plus 2xc and minus x squared. Now I can get rid of my x squareds because I've got a minus x squared on both sides. So if I add x squared to both sides, I'll get b squared equals a squared minus c squared plus 2xc. This is starting to look a lot better. We don't have our h's now, and we've got b squareds and a squareds and c squareds. That's looking good. But we do still have an x, so we need to work out how to eliminate our x. If I come back and have a look at my equation at the top, I know that cos A is equal to x over b. Well, I can rearrange that to say x is equal to b cos A. Then all I need to do is substitute that into my equation. So we get b squared equals a squared minus c squared plus 2. And instead of x, I'm going to write my b cos A. And we still have our c there. So we get b squared equals a squared minus c squared plus 2bc cos A. To finish it off, I'm just going to leave the a squared on the side it's on, take everything across to the other side, gives me b squared plus c squared minus 2bc cos A. And that is the cosine rule. The cosine rule at A level is given in the OCR formula book, so you don't need to learn it. It's one of the few trig identities that you are given. Now let's have a go at applying it to a question. So we've got a triangle, we've got three sides, we're asked for the angle. I can't use the sine rule because for the sine rule I need a side and an angle, and then I'm looking for one of the other ones. Because we've got three sides but no angle, it must be the cosine rule. So I'm going to start off by writing out my cosine rule. A squared equals b squared plus c squared minus 2bc cos A. If we have a look back at our original triangle, you'll notice that the A and the side which is small a are opposite each other. So in our example here, if this is theta, well, in our cosine rule this is A, this side is going to be little a, and then B and C are the sides adjacent to the angle. So I can put in my numbers, I can say a squared, well that's going to be 6 squared equals b I'm going to say is 5 squared, c I'm going to say is 4 squared, minus 2 times 5 times 4 cos, and a is theta, that's what we're looking for, and now all I need to do is rearrange it. So I'll get 36 equals 25 plus 16 minus 2 times 5 is 10 times 4 is 40. So we get 40 cos theta. So I'm going to get 36, take away 25, take away 16, gives me minus 5 equals minus 40 cos theta. So we want to find where cos theta is equal to an eighth. So theta is equal to, and I'm just going to do inverse cos of my 1/8, and we get 82.8 degrees. So it really is just a case of substituting numbers into the formula and making sure that you get your labels the right way around. I hope that clears up any questions on the cosine rule, and that with a bit of practice you're now able to do any exam question which crops up.